The cosmos holds more secrets than we have ever known. Every time we point our telescopes upward, we uncover something that defies explanation, something wonderfully bizarre. Today, we are embarking on a journey through 30 of the most mind-bending space oddities just discovered by astronomers. You will discover planets with skies of sand, stars that refuse to die, and invisible galaxies made of pure mystery. What strange force could make a black hole dance, and why is there a colossal cold spot on Jupiter larger than our entire world? By the end of this exploration, you will have a front row seat to the very edge of our cosmic understanding. What is the most surprising thing you believe is still waiting for us in the dark? Jupiter holds a secret chill far deeper than anyone ever anticipated. Astronomers have discovered a colossal dark patch on the giant planet, a feature so immense it could swallow our entire world whole. This is not the famous Great Red Spot, that ancient churning hurricane of gas. This is something entirely different, a zone of profound cold they call the Great Cold Spot. While the red spot is a storm of swirling heat and vibrant color, this new spot is a vast, shadowy region where the upper atmosphere plunges to temperatures hundreds of degrees colder than the surrounding clouds. It is a persistent ghost in Jupiter's roiling atmosphere, sometimes fading, sometimes strengthening, but always there. So how does a planet bathed in the sun's energy and boiling with internal heat maintain such a frigid scar? The leading theory points to the planet's spectacular auroras. These brilliant light shows at the poles are powered by a torrent of energetic particles from the sun, and they may be funneling energy away from the upper atmosphere, creating a massive vortex of cold gas. It is a complex atmospheric dance, a phenomenon we are only just beginning to understand, proving that even our solar system neighbors hold deep and surprising mysteries. But the solar system is not the only place hiding cosmic anomalies. Far beyond Jupiter, in the deepest black of intergalactic space, lies a region of nothingness so vast it defies belief. This is the Boötes Void, a spherical desert of emptiness stretching across 330 million light-years. For decades, astronomers have called it the Great Nothing, a place where galaxies are almost entirely absent. Finding a single galaxy here is like finding one lone, quiet house in the middle of an entire continent devoid of any other town or road, and now they have found one. Deep within this void, astronomers have identified an isolated, ancient galaxy, a solitary beacon shining in an ocean of dark. This galaxy is not like the vibrant, spiral structures we are familiar with. It is old, its stars having formed billions of years ago, and it is incredibly lonely. Its very existence in such an empty neighborhood is a direct challenge to everything we thought we knew about how galaxies form and gather. Our models suggest that galaxies should cluster together, drawn into cosmic cities by the irresistible pull of dark matter. A galaxy this old and isolated, sitting alone in the void, suggests that the distribution of matter in the early universe was far more patchy and strange than we ever predicted. It is a fossil from the dawn of time, a quiet testament to a much emptier and far more mysterious cosmic beginning. This cosmic emptiness is suddenly shattered by a violent and rhythmic disturbance. Far from the silent void, astronomers have detected a pair of supermassive black holes locked in the most extreme gravitational dance imaginable. These are not solitary monsters lurking in the hearts of their respective galaxies. They are the final, inseparable core of two galaxies that have already collided and merged. Now, these black holes, each weighing billions of times the mass of our Sun, are whirling around each other in a tight, frantic orbit. Their movement is so fast they complete a full loop in just about 2 Earth years. To put that in perspective, the solar system takes 230 million years to orbit our own galaxy. This is a dizzying, cosmic waltz at a breakneck speed. Detecting this dance required a brilliant piece of astronomical detective work. Since we cannot see the black holes directly, scientists had to observe the regular, flickering glow from a vast disk of superheated gas and dust called an accretion disk that surrounds one of them. As the black holes swing around each other, their immense gravity tugs and distorts this disk, causing its light to pulse with a predictable rhythm, a clear signal of their orbital period. This is the most compelling evidence ever found for a binary system of supermassive black holes, a pair destined for a cataclysmic merger. Their final collision, which could happen in just about 10,000 years, will not be a quiet event. It will shake the very fabric of the universe, sending out ripples in space-time known as gravitational waves. These waves will be far more powerful than any we have detected before, a testament to the incredible forces at play when the universe's most massive objects decide to dance. That frantic cosmic dance is a reminder of how much we still have to learn, and sometimes the strangest clues come not from distant galaxies, but from visitors passing through our own cosmic backyard. A few years ago, a mysterious object named Oumuamua tumbled into our solar system, the first ever confirmed traveler from another star. Its arrival sparked immediate fascination, but the true mystery began as it started to leave. Scientists tracking its path noticed something deeply unusual. Oumuamua was accelerating, speeding up in a way that gravity alone could not explain. Comets often exhibit non-gravitational acceleration when the sun heats their icy surfaces, causing them to vent gas and dust like a natural rocket engine. But Oumuamua showed no visible coma, no surrounding cloud of gas or dust, no tail. It was a silent, dark, and seemingly inert rock, yet something was pushing it. This bizarre behavior ignited a firestorm of debate that still rages today. Was it a very strange type of comet, one that released gas in a way we had never seen before, perhaps from hidden pockets of exotic ices? Or was it a new kind of asteroid, a porous, dust-free object that somehow managed to accelerate without any of the usual signs? The most tantalizing, though highly speculative, theory suggests it could have been something more exotic, like a fragment of a Pluto-like world ripped from its home system, or even a light sail from an advanced civilization, using the pressure of starlight for propulsion. While most scientists favor a natural explanation, the very fact that such extraordinary ideas are on the table shows just how puzzling this object remains. Oumuamua was a fleeting guest, but its legacy is permanent, forcing us to question our categories and seriously consider that the next strange rock in the sky might not be a rock at all. The silent acceleration of Oumuamua pales in comparison to a signal with a terrifyingly perfect rhythm. Deep within our own galaxy, astronomers have recorded a cosmic drumbeat emanating from a corpse. This is the heartbeat of a magnetar, a type of neutron star so dense that a single teaspoon of its material would weigh billions of tons. But its density is not its most extreme feature. A magnetar possesses a magnetic field so powerful it defies human comprehension. If you brought one halfway to the moon, its magnetic field would erase the data from every credit card on Earth. These objects are the universe's ultimate magnets, and one of them is sending out a radio pulse with the regularity of a metronome. This signal is not a simple flash. It starts with a loud, sharp peak followed by a quieter, fluctuating tail, and then a period of silence, repeating every 10 seconds with unerring precision. What natural engine could possibly produce such a clean, repeating signal from an object churning with forces that rip atoms apart? The leading theory points to vibrations within the star itself. Picture the magnetar's solid, crystalline crust, a shell under unimaginable strain from the twisted magnetic fields locked within. A sudden starquake, a fracture in this crust, could send powerful vibrations rippling through the entire body, causing it to ring like a bell. These oscillations would then twist the magnetic field lines anchored to the surface, pumping energy out into space as a focused beam of radio waves with every single shake. Each pulse is a direct echo of the star's internal tremor, a seismic event on a stellar scale. This regular heartbeat gives us a unique probe into the interior of an object where the laws of physics are pushed to their absolute limit, helping us understand how matter behaves under conditions we could never hope to recreate. While the magnetar's rhythm reveals the inner workings of a dead star, other worlds showcase atmospheres of pure alien fury. Astronomers have found a planet where the sky itself is forged from metal. This is a hot Jupiter, a type of gas giant that orbits perilously close to its home star, and its atmosphere is so scorching that it contains vaporized titanium. On Earth, titanium is a strong, solid metal used in everything from jet engines to jewelry. But on this distant world, the daytime temperatures are so brutally hot that titanium oxide exists not as a solid or a liquid, but as a gas saturating the upper layers of the atmosphere. Detecting this metallic sky was a feat of cosmic spectroscopy. As the planet passed in front of its stars, starlight filtered through its atmosphere. Different elements and compounds absorb specific wavelengths of light, leaving behind a unique chemical fingerprint in the starlight that reaches our telescopes. The data revealed the clear, unmistakable signature of gaseous titanium oxide. This discovery is crucial because titanium oxide plays a dramatic role in the planet's weather. It acts as a powerful heat absorber. In the upper atmosphere, this gaseous metal soaks up the immense radiation from the nearby star, creating a searing hot layer that sits above the cooler air below. This is called a temperature inversion, and it is the same phenomenon that happens in our own stratosphere, where ozone traps heat. But on this world, the effect is dialed up to an unimaginable extreme. The presence of this titanium sky fundamentally changes how energy circulates across the planet, potentially locking entire hemispheres in a permanent, scorching heat wave while leaving others in relative, though still infernal, shadow. This is not just a planet with strange chemistry. It is a world with a metallic sun shield, a place that teaches us just how diverse and violently beautiful planetary systems can become. That metallic sky is a stark reminder of how alien other worlds can be, but some of the cosmos's greatest secrets are not just alien, they are almost entirely invisible. Astronomers have found a ghost, a galaxy that seems to be made of almost nothing at all. This is a dark galaxy, a vast collection of matter that holds the mass of a typical galaxy, but with a crucial and baffling difference. It contains almost no stars, where a normal galaxy like our Milky Way blazes with the light of hundreds of billions of suns. This structure is a shadowy phantom, a cosmic skeleton of dark matter with only a faint, wispy smattering of stars to hint at its existence. So how do you find something that does not emit any light? The discovery relied on a cosmic trick of the light, a phenomenon known as gravitational lensing. The immense, invisible mass of the dark galaxy warps the very fabric of space around it, acting like a lens that bends and distorts the light from more distant galaxies lying behind it. By meticulously mapping the subtle, telltale distortions in the light of these background galaxies, astronomers could trace out the shape and heft of the invisible object causing the warping. They were essentially seeing the shadow of the dark galaxy cast upon the light of the universe. This phantom structure exerts a powerful gravitational pull, proving it is there and that it is massive, yet it has failed to ignite the star-forming fires that light up a normal galaxy. Its existence is a profound clue in the long-standing mystery of dark matter. For decades, our best models of the universe have suggested that dark matter halos, these vast, invisible scaffolds, should be far more common than the bright galaxies we see. This dark galaxy appears to be one of those pure halos, a building block of the cosmos that, for reasons we do not yet understand, never managed to gather enough regular gas to form stars. It is the ghostly, silent majority of the cosmic population, a direct observation that brings us one step closer to understanding the invisible framework upon which the entire visible universe is built. These cosmic heartbeats, however, are not always perfectly steady. Sometimes the universe's most reliable clocks simply skip a beat, Deep in the cosmos, astronomers observe pulsars, the rapidly spinning cores of dead stars, which send out beams of radiation with a precision that rivals our best atomic clocks. But every so often, one of these cosmic lighthouses does something utterly bizarre. Without any warning, its spin rate suddenly jumps, speeding up by a tiny but significant fraction in a sudden, violent event known as a glitch. It is as if a spinning ice skater, rotating at a constant, graceful pace, were to abruptly pull their arms in even tighter for just an instant, causing a frantic, unexpected whirl. These glitches are more than just a curiosity. They are a direct window into the alien physics of a neutron star's interior. The leading explanation points to a dramatic internal struggle. Picture a neutron star as a complex, layered sphere. It has a rigid, crystalline crust of iron floating on a surreal interior called a superfluid. This superfluid is a bizarre state of matter that has zero viscosity, meaning it flows without any friction at all. While the star's solid crust spins at one constant rate, slowed over time by the energy it beams into space, this internal superfluid can keep spinning faster, untouched by the braking forces affecting the crust. The two components become decoupled. As this difference in spin builds up over months or years, immense stress develops. Finally, the strain becomes too much and the crust suddenly cracks in a starquake. This fracture allows the superfluid's faster momentum to transfer outward in a sudden torrent, violently coupling with the crust and giving the entire star a swift, observable kick. This glitch is the seismic echo of that internal transfer. A direct signal from matter so dense it is on the very brink of collapsing into a black hole. By studying these tiny hiccups, we are essentially doing remote ultrasounds on these stellar corpses, learning about the behavior of matter under pressures and densities that defy every law of physics we can test on Earth. This planet does not belong to any star. It is a rogue world, a dark wanderer cast adrift in the cold space between solar systems, and yet it produces one of the universe's most beautiful spectacles. Astronomers have discovered a free-floating planet, untethered to any sun, that boasts its own powerful, shimmering auroras. This creates a profound cosmic puzzle. On Earth, our auroras are painted across the sky by the solar wind, a constant stream of charged particles from our sun that interacts with our planet's magnetic field. But this lone world has no star to provide such a wind. So what is the source of its ghostly light show? The answer lies in a fundamental and brutal interaction with the void itself. The planet is thought to possess a strong, dynamic magnetic field. As it travels at high speed through the galaxy, it does not move through a perfect vacuum. It plows through the thin, scattered gas and dust of the interstellar medium. This material, though incredibly diffuse, is still composed of charged particles. Scientists believe the planet's powerful magnetic field acts like a cosmic fishing net, scooping up these particles and funneling them toward its poles. When these captured particles slam into the planet's upper atmosphere, they energize its gases, causing them to glow with the same ethereal light we see in our own polar skies. It is a light generated by motion alone, a beacon born from the friction of a world moving through the galactic dark. There is another, even more tantalizing possibility. This nomadic planet might not be entirely alone. Just as Jupiter's moons interact with its magnetic field, this rogue world could be orbited by a large volcanic moon. Such a satellite, heated internally by the gravitational tug of war with its planet, could be spewing vast clouds of ionized material into space, creating a localized plasma environment that its parent planet's magnetic field could then seize upon to power the auroras. This would mean the light in the sky is not just a product of interstellar travel, but a sign of a complex, hidden system, a tiny, self-contained solar system drifting silently through the night, its only sun the faint, colorful shimmer of an atmospheric ghost. Even the most stable stars can betray a violent past. astronomers have discovered a sun-like star with a terrible secret, its light revealing the chemical ghosts of devoured worlds. This is a stellar cannibal, a star that has consumed its own planetary children. The evidence was found not through a telescope image, but by dissecting the star's very essence using spectroscopy. By breaking its light into a rainbow of colors, scientists can identify the unique fingerprints of individual elements present in the star's outer atmosphere. In this particular star, they found an unnaturally high abundance of rocky minerals, elements like iron, silicon, and magnesium. These are the building blocks of terrestrial, Earth-like planets. The problem is, a star of this age and type should have long ago seen these heavy elements sink down into its dense interior, leaving a much cleaner, hydrogen-rich atmosphere. The presence of such a large amount of planetary material in its outer layers is like finding undigested bones in a stomach, a clear sign of a recent and catastrophic meal. The chaotic dynamics that could lead to this are terrifying. Imagine the gentle gravitational balance of a solar system being violently upset. Perhaps a close pass by another star sent the inner planets careening out of their stable orbits, spiraling inward toward their own sun. Or maybe the complex gravitational dance between giant planets, a cosmic game of billiards, flung a smaller, rocky world directly into its stellar parent. As the planet plunged into the star, it would have been torn apart by immense tidal forces, vaporized, and then mixed into the star's outer layers, its unique chemical signature forever staining the star's atmosphere. This discovery holds a mirror to our own solar system's future. Billions of years from now, as our sun exhausts its hydrogen fuel and begins to swell into a red giant, its outer layers will expand to engulf the inner planets. Mercury, Venus, and almost certainly Earth will be consumed, their material dissolving into the sun's fiery envelope. This distant cannibal star is not a monstrous outlier, but a preview of the fate that awaits most planetary systems, a sobering reminder that even the suns we orbit are not permanent guardians, but powerful forces that can, in the end, reclaim everything they helped create. The cannibal star's violent history is a stark reminder of creation's violent origins, yet the birth of a star can be just as dramatic. A new infrared image reveals a cosmic caterpillar, a dark, wriggling filament of gas and dust stretching an incredible light year across the void. This is not a living creature, but a stellar nursery, a dense core within an infrared dark cloud where new suns are just beginning to ignite. Inside this colossal structure, pockets of gas are collapsing under their own immense weight, heating up as they contract. These are protostars, the very first stage in a star's multi-million-year journey to brilliance, but the caterpillar's unique shape is not an accident. It is sculpted by two powerful, invisible forces, turbulence and magnetic fields. Imagine the cloud as a vast, chaotic sea. Turbulence creates swirling eddies and waves within the gas, stirring it and causing it to clump together in certain regions. At the same time, magnetic fields thread through the entire structure like cosmic threads, guiding and channeling the flow of material, preventing it from collapsing too quickly and pinching it into this long, slender form. The result is a string of dense beads along the caterpillar's back, each one a potential star system in the making. This object is a rare and precious snapshot, a fossilized moment in time capturing the earliest phases of stellar gestation, long before nuclear fusion ever lights up its core. It shows us that the path to becoming a star is not a simple, smooth collapse, but a complex, messy battle between gravity's pull and the fierce resistance of magnetic and turbulent forces, all working together to weave the fabric of new suns. Our universe reserves its most chaotic dances for the darkest corners of galactic centers. While a pair of dueling black holes is a cosmic spectacle, astronomers have now found a system where the waltz becomes a frantic, three-body frenzy. Deep within a galaxy forged from multiple violent mergers, not two, but three supermassive black holes are locked in a gravitational embrace. Each of these monsters contains the mass of millions, even billions of suns, all orbiting a shared center of gravity in the galaxy's core. The formation of such a triplet is a testament to the violent history of galaxies. It begins with two galaxies colliding, their central black holes sinking to the core and beginning their own orbital dance. Then a third galaxy smashes into this already unstable pair. Its black hole is dragged into the mix, creating a chaotic three-way gravitational standoff. The dynamics of this system are exponentially more complex than a simple binary. The black holes do not follow simple, elegant orbits. Instead, they engage in a chaotic gravitational tug of war, their paths constantly perturbed by the other's immense pull. One might be flung out on a wide, looping path, only to be slingshotted back inward by the combined gravity of the other two. This creates an unpredictable, ever-changing orbital ballet where long-term stability is nearly impossible. The eventual fate of this system is a cacophony of ripples in spacetime. When two black holes merge, they produce gravitational waves. In this triplet, the gravitational wave signal will be far more complex, a messy, overlapping chirp that reflects the chaotic final moments before the first two partners collide. But the dance does not end there. The newly merged, even more massive black hole would then have to settle into an orbit with the sole survivor, generating a second, distinct wave signal. This stepped, chaotic merger process provides a completely unique signature, one that future observatories hope to detect directly. It is a window into the most extreme gravitational environments in the universe, where the fundamental fabric of reality is stirred by not one or two, but three invisible spoons. The universe just presented us with a stellar corpse that breaks all the established rules. Astronomers have found a neutron star that simply should not exist, an object that fits into no known category. It possesses the impossibly powerful magnetic field of a magnetar, yet it behaves in many ways like a common pulsar. This cosmic hybrid defies our neat classifications and forces a complete rethinking of how these dense stellar remnants evolve. For decades, we thought neutron stars followed one of two distinct paths. On one side, you have pulsars, the rapidly spinning lighthouses of the cosmos, with strong but predictable magnetic fields. On the other, you have magnetars, the volatile, magnetic monsters whose fields are 1,000 times stronger, capable of generating starquakes and releasing flares of energy that can be sensed across the galaxy. These were two separate families, but this new object is both. Its magnetic field strength is off the charts, squarely in magnetar territory, yet it lacks the violent outbursts and X-ray flares that define those magnetic tyrants. Instead, it spins steadily and quietly like a pulsar, beaming radio waves out into the void with a calm regularity that belies the ferocious forces trapped within its core. So how can one object possess such extreme magnetism without the corresponding volatility? The discovery suggests our two-path model for neutron star evolution is far too simple. Perhaps all neutron stars are born with the potential for such immense magnetic power. The difference between a magnetar and a pulsar might not be their origin but their fate. It could depend on the precise conditions during the supernova explosion that created them, the initial spin of the core, or the complex, turbulent dynamics of the magnetic field as it froze into the newly formed neutron star's crust. This impossible star might be a rare specimen that captured a perfect, stable balance of these forces, a quiet giant holding its immense power in check. Or it could represent a previously unknown transitional phase, a magnetar that is slowly calming down, or a pulsar that is just beginning to awaken its hidden magnetic strength. This single, defiant object tells us that the life of a stellar corpse is not a simple story of two choices, but a rich and varied journey with many possible pathways, each leading to a different kind of cosmic wonder. Far from the chaotic centers of galaxies, a gentler cosmic dance offers a different kind of mystery. Astronomers have found compelling evidence for a moon, not a planet, orbiting a gas giant within its star's habitable zone. This is not a direct photograph, but a story told in shadows and wobbles. The discovery hinged on the transit method, watching for the tiny, periodic dimming of a star's light as a planet passes in front of it. In this case, the data revealed something extra. Along with the primary dip from the gas giant, there were secondary, much smaller dips in brightness, and sometimes the planet itself seemed to transit slightly early or late. The best explanation for this intricate pattern is the gravitational tug of a large moon, its own transit causing the additional dimming and gently pulling its parent planet back and forth in its orbit. This exomoon candidate is a behemoth potentially larger than Earth, and it orbits a Jupiter-like world. But the most thrilling detail is its location, circling within the region where temperatures could allow liquid water to exist on a surface. This immediately brings to mind worlds like Jupiter's moon Europa, an ice-covered sphere with a vast global ocean hidden beneath its frozen crust. The possibility that this distant exomoon could be a similar water-rich world is breathtaking. Imagine a moon with a rocky core wrapped in a deep, dark sea, all under the soft light of its parent star, with the colossal curve of its gas giant host hanging permanently in its sky. It is a place where the ingredients for life, water, energy, and stability could theoretically come together not on a planet but on a satellite. This single candidate challenges our planet's centric search for life and opens up an entire new class of worlds to dream about, suggesting that the most promising habitats in the cosmos might not be planets at all, but the moons that orbit them. The silence of deep space is sometimes broken by a scream. Fast radio bursts are among the most energetic and baffling phenomena we have ever detected, blasting out more power in a millisecond than our sun emits in 3 days. For years, these events seemed utterly random, appearing from any point in the sky without warning, but then astronomers found one that breaks the pattern. A fast radio burst from a distant galaxy is repeating not randomly but on a strict, predictable schedule. It erupts with violent radio noise for a window of roughly 90 days, then falls completely silent for another 67 days, only to start the cycle all over again. This precise 157-day rhythm is a monumental clue, a cosmic metronome ticking in the void. So what kind of celestial engine could possibly shut on and off with such perfect timing? The leading theories point to an object in a complex dance. One compelling idea involves a highly magnetized neutron star, a pulsar that is not spinning perfectly upright. Like a wobbling top, it could be precessing, its magnetic poles slowly swaying over time. For months, one of its powerful beams would point toward Earth, and we would see the regular burst. Then, as it wobbles, the beam would sweep away from our line of sight, and the bursts would vanish for months, only to return when its precession brings the beam back around. Another, even more dynamic, theory suggests the neutron star is locked in a tight, eccentric orbit with a massive companion, perhaps another star or a black hole. In this scenario, the bursts are only triggered when the neutron star swings closest to its partner, a point called periastron, where tidal forces or interactions with the companion's wind could violently excite its magnetic field. The long silent period would then be the slow, distant arc of its orbit. This regular pattern is more than a curiosity, it is a roadmap. By timing the cycle, astronomers can now predict when the burst will be active, allowing telescopes around the world to focus on it during its active window. Each new detection helps us triangulate the physics of its source, ruling out some of the wilder theories and bringing us closer than ever to understanding what or who is sending these incredibly powerful, timed signals across the universe. Even the final breath of a star can forge the seeds of life. Astronomers have made a stunning discovery within the ghostly glow of a planetary nebula, the beautiful, expanding shell of gas cast off by a dying sun. Drifting through this cosmic funeral shroud are vast quantities of buckyballs, the largest and most complex molecules ever found in the void of space. A buckeball is a hollow cage of 60 carbon atoms arranged in a perfect soccer ball pattern of pentagons and hexagons. Its official name is Buckminster Fullerene, named after the architect who designed similar geodesic domes. Finding these intricate molecular structures in the turbulent winds of a dying star was a complete surprise. They form in the star's cooling outer layers where carbon atoms, forged in the star's own nuclear furnace, link up in the final moments before being blasted into interstellar space. These are not simple chains of atoms, they are architectural marvels, tiny carbon cages stable enough to survive the violent journey. Their presence is a game-changer for our understanding of cosmic chemistry. We have long known that space contains simple molecules, but buckeballs represent a leap in complexity. They are robust carbon containers, capable of shielding other molecules within their hollow cores or acting as scaffolding upon which even more complex organic chemistry can occur. This means that the very processes of stellar death are actively seeding the galaxy with sophisticated probiotic material. Every planetary nebula with its beautiful, glowing clouds could be a factory producing these potential building blocks, scattering them into cosmic clouds where new planets and perhaps new life may one day form. Some stars are not content to simply orbit their galactic home. They run. One such star is a hypervelocity fugitive, rocketing through the halo of our Milky Way at a speed so tremendous it is destined for the cold intergalactic void. This is not a native star being flung out by our own supermassive black hole. By tracing its path backward across the cosmos, astronomers found its origin points to a dramatic escape from a neighboring galaxy, the Large Magellanic Cloud. It appears to have been violently ejected from that smaller galaxy's heart, a place now suspected to harbor its own, previously unseen, central black hole. The story of its escape is written in its very chemistry. The star's composition is strikingly young and metal-rich, a perfect match for the stellar populations found within the turbulent central regions of the Large Magellanic Cloud. This chemical fingerprint is the final piece of evidence, confirming it was born in that dense, chaotic environment and not in the quieter outskirts of our own galaxy. The most plausible ejection mechanism is a gravitational slingshot. Picture a binary star system, two stars orbiting each other, wandering too close to the invisible supermassive black hole at their galaxy's core. The immense gravity of the black hole would violently tear the pair apart. One star would be captured into a tight orbit, while the other would be flung away at an incredible speed like a stone from a sling. This stellar cannonball was set on its current trajectory by that single, catastrophic encounter millions of years ago. Now it carries that momentum across the gulf between galaxies, a permanent exile and a speeding tracer bullet that helps us map the hidden gravitational forces of our cosmic neighborhood. Our galaxy holds a world that would make even the deserts of Tatooine seem simple. Astronomers have discovered a planet locked in a gravitational ballet with not one, not two, but three separate suns. This is a circumbinary planet in a triple star system, a place where the very definition of a day is a complex cosmic calculation. The planet itself orbits a pair of stars that are locked in a tight mutual dance. These two central suns whirl around each other so closely that from the planet's surface, they might appear as a single, elongated, or even peanut-shaped brilliant object. Meanwhile, much farther out, a third star orbits this entire inner system, a distant but dominant gravitational partner. For a planet to exist here at all is a delicate miracle. Its orbit must be wide and stable enough to avoid being violently ejected by the constantly shifting gravitational pulls from all three stars. It is like trying to balance a marble on a plate held by three people who are all spinning at different speeds. The planet has found a sweet spot, a gentle path around the central binary pair that is largely immune to the tugs from the distant third star. This orbital stability is what allows it to persist in what should be a chaotic and destructive environment. Detecting this world was a monumental challenge. Using the transit method, scientists had to sift through the light of 3 stars, looking for the tiny, periodic dip in brightness caused by the planet passing in front of one of them. But the light itself was constantly changing as the stars eclipsed and passed by one another, creating a flickering background against which they had to find the planet's faint signal. It was an exercise in patience and computational power, isolating a single, repeating whisper from a symphony of stellar noise. Imagine standing on the surface of this world. Your sky would be a spectacle of multiple suns, casting complex and shifting shadows throughout the day. There would be times when all 3 are visible, creating a triple sunrise that paints the horizon in layered hues of gold and red. Other times, one star might set while the other 2 remain high, or the central binary pair could eclipse each other, creating a daily celestial show of dimming and brightening unlike anything in our own solar system. The concept of seasons would be dictated by the slow, grand orbit of the entire system around that distant third sun, leading to epochs of perpetual daylight or strange, multi-hued twilight. This is not a world of simple cycles, but a permanent, dazzling exhibition of celestial mechanics playing out overhead. That triple-starred world is a testament to the intricate architecture of our cosmos, but the true scale of that structure is almost beyond comprehension. For the first time, astronomers have directly photographed a single thread of the cosmic web, the universe's fundamental skeleton. This vast, invisible network of dark matter is believed to connect all galaxies in a sprawling, 3-dimensional tapestry, and we have finally seen one of its glowing strands. The challenge in observing this cosmic framework has always been its profound darkness. The filaments themselves are made of dark matter, which emits no light, and the ordinary gas that traces their shape is so diffuse it is nearly transparent. To illuminate this ghostly highway, scientists use the most brilliant beacon in the distant universe, a quasar. This is the intensely luminous core of an ancient galaxy, powered by a voracious supermassive black hole. They position the quasar like a cosmic flashlight, its powerful radiation shining directly along the line of a predicted dark matter filament. As the quasar's light traveled for billions of years toward Earth, it passed through the filament. The hydrogen gas within that structure absorbed specific wavelengths of the quasar's brilliant light, imprinting a unique signature upon it. By analyzing this altered light with immense precision, astronomers could not only detect the filament's presence but actually map its extent, revealing a tendril of gas stretching across an incredible 3 million light-years. This confirmed filament is far more than a wispy cloud. It is a dense, coherent structure, exactly as predicted by our models of cosmic evolution. This observation is a direct confirmation of a foundational theory, proving that galaxies do not form randomly. They are born at the dense intersections of this dark matter web, growing like dewdrops on an invisible spider's silk. Seeing this single thread makes the abstract concept of a universe woven together into a tangible, breathtaking reality, revealing the hidden highways upon which galaxies are built. A star died and then it refused to disappear. Astronomers have witnessed a cosmic paradox, a white dwarf star that experienced a supernova explosion and lived to tell the tale. This stellar zombie underwent what is classified as a Type IX supernova, a weaker, slower, and ultimately failed version of the typical stellar detonation that should have annihilated it completely. The discovery was made when scientists compared historical images of a supernova event with new, deeper observations of the same patch of sky. They expected to find nothing, the empty space where a star once was. Instead, they found the star itself still shining, albeit dimmer and forever changed. It had survived its own death. The mechanism behind this partial explosion is as fascinating as it is violent. A typical Type Ia supernova, the kind used to measure cosmic distances, involves a white dwarf stealing so much material from a companion star that it reaches a critical mass limit. This triggers a runaway thermonuclear explosion that utterly shreds the white dwarf, leaving no core behind. The Type IX event is different. It is a fizzle, a spluttering fuse. In this scenario, the explosion likely begins deep within the white dwarf, but fails to propagate all the way through the star with the same ferocity. Instead of being completely vaporized, the star is blasted from the inside out. The outer layers are ejected into space in a great, expanding shell, but the dense, Earth-sized core of the white dwarf is kicked away, bruised and battered, but still intact. This zombie star is that surviving core, now sent flying through space at a tremendous speed, a burnt-out cinder that somehow endured the inferno. This discovery fundamentally changes our understanding of stellar life cycles. It proves that supernovae are not a single, monolithic class of event with one inevitable outcome. There is a spectrum of violence, and sometimes the universe's most powerful explosions can be strangely incomplete. The existence of these zombie stars suggests that the process of igniting a white dwarf is more complex than a simple on-off switch. The angle of the ignition flame, the purity of the material, or the strength of the magnetic fields could all play a role in determining whether a star dies completely or lives on as a ghost of its former self. These stellar survivors are more than just cosmic curiosities. They are direct probes into the heart of the supernova mechanism itself, showing us that even in death, stars can defy our expectations. Even the most alien worlds can find a familiar echo in the strangest of places. Imagine a world where the forecast calls for scorching winds and a rain of sand. Astronomers have discovered an exoplanet where the high-altitude clouds are not made of water vapor, but of fine, silicate dust, essentially sand. This is a planet so profoundly hot that its very geology is thrown into the sky. Located perilously close to its host star, the planet is tidally locked, with one hemisphere perpetually facing the stellar inferno. The dayside temperatures here are so extreme, they can soar beyond 2,000 degrees Fahrenheit, hot enough to vaporize rock. Just as water evaporates from our oceans here on Earth, the searing heat on this world causes silicate and metal-rich rocks on the surface to sublimate, turning directly from solid stone into a gaseous vapor that rises into the atmosphere. As this mineral vapor ascends to higher, cooler altitudes, it condenses back into tiny droplets of liquid rock or solidifies directly into microscopic grains of sand. These particles form high, hazy layers of silicate clouds, creating a pale, shimmering sky that obscures the surface below. But the alien weather does not stop there. Just as water droplets in our clouds grow heavy and fall as rain, these sand particles also eventually succumb to gravity. They begin to coalesce, growing larger and heavier until they start to fall back toward the planet's surface. However, the journey down is a brutal one. As the sand grains descend into the lower, hotter layers of the atmosphere, they encounter rising temperatures so intense that they are vaporized once again, turning back into a gas long before they can ever reach the ground. This creates a permanent, global cycle of sand evaporation and sand precipitation, a weather system where it perpetually rains sand that never lands. Observing this world's atmosphere presented a monumental challenge. Scientists used the transit method, watching for the star's light to dim as the planet passed in front of it. But the real clues came from studying the starlight that filtered through the planet's atmosphere. The spectral signature revealed the distinct chemical fingerprints of vaporized silicates and the scattered light from countless tiny sand particles, a clear sign of these high mineral clouds. This bizarre world is a stunning example of how extreme conditions can twist familiar processes into something entirely new. A place where the very ground you stand on could one day become a cloud in a sky of fire. Yet this cosmic scaffolding is not always where we expect it to be. A galaxy known as NGC 1052DF2 stands as a profound cosmic rebel, a place where the fundamental rules of the universe appear to have been rewritten. According to every established model, a galaxy of its size and brightness should be dominated by the gravitational grip of dark matter, that invisible glue that holds galaxies together. But when astronomers measured the velocities of its star clusters, they found something astonishing. These clusters were moving far too slowly. Their speeds indicated that the total mass of the galaxy was almost exactly equal to the mass of its visible stars. There was simply no room left for dark matter. This finding sent shockwaves through the field of cosmology. The evidence came from a careful analysis of the galaxy's globular clusters, dense swarms of ancient stars that orbit the galactic center. The speed of these clusters is a direct tracer of the galaxy's total gravitational pull. In a normal galaxy, the stars and clusters whip around so fast that the visible matter alone cannot possibly hold them together, requiring the presence of a massive dark matter halo. But in this oddball galaxy, the clusters drift along at a leisurely pace, their motions perfectly explained by the gravity of the stars we can see. The immediate counter-argument was that this galaxy must have been torn apart, its dark matter stripped away by a close encounter with a larger neighbor. Yet further observations revealed it is an isolated galaxy, floating alone in a quiet part of space with no large galaxies nearby to have robbed it. This left scientists scrambling for other explanations. Perhaps our measurements of the galaxy's distance are wrong, throwing off the mass calculations. Or maybe the galaxy is not a pristine relic but the shattered debris of a previous collision, a tidal dwarf galaxy that formed from pure visible matter. The problem is, our best simulations show that forming a stable, long-lived galaxy without the stabilizing framework of dark matter is incredibly difficult. If this galaxy truly lacks dark matter, it creates a monumental paradox. The entire foundation of our modern cosmology rests on the presence of dark matter as the primary architect of cosmic structure. We use its gravitational influence to explain how galaxies form, how they rotate, and how they cluster together. A galaxy with no dark matter directly challenges that narrative. It suggests that dark matter and visible matter can, under some mysterious circumstances, be separated. This single anomaly forces us to question whether our understanding of gravity itself needs revision, or if the nature of dark matter is even more elusive and complex than we ever dared to imagine. This ancient light traveled for over 13 billion years to reach us, a journey so long it shows us the universe in its raw infancy. We see it only because of a cosmic coincidence, a perfect alignment with a massive galaxy cluster closer to us. This cluster acts as a gravitational telescope, its immense gravity warping the fabric of space around it. The background light from the primitive galaxy follows this curved path, bending around the cluster and becoming magnified dozens of times. Without this natural lens, the galaxy would be a faint, invisible smudge, far beyond the reach of even our most powerful telescopes. The magnified image reveals a chaotic, clumpy structure, a far cry from the elegant spirals and smooth ellipticals we see in the modern universe. This galaxy is a cosmic building site, a place where the first stars are just beginning to assemble. Its composition is strikingly pure, dominated by hydrogen and helium, the primordial elements forged in the Big Bang. It lacks the heavy metals like carbon, oxygen, and iron that are common in later galaxies and are essential for planet formation. This tells us we are looking at a member of the very first generation of galaxies, a population 3 system where the stars are made from nothing but the universe's original ingredients. These first stars would have been colossal, burning hot and fast before exploding as supernova, seeding the cosmos with the first heavy elements. The star formation rate within this galaxy, while vigorous for its time, is incredibly slow by today's standards. It might form the equivalent of only 1 or 2 sun-like stars per year, a gentle trickle compared to the stellar factories in later galaxies. This faint, distant glow is a direct portal to the cosmic dawn, showing us a time when galaxies were just learning how to be galaxies, and the entire universe was taking its first, tentative steps toward the complexity we see today. A mature star, much like our own sun, holds a secret it should have outgrown long ago. This star is surrounded by an enormous, cold ring of dust, the kind of feature astronomers expect to find only around infant stars. In a young system, such a ring is a natural part of the planet-forming process, a swirling disk of debris left over from the star's birth. But this star is old. Its planets, if it has any, would have coalesced billions of years ago. By all rights, this primordial dust should have dissipated, either blown away by stellar winds or drawn inward by gravity, leaving a clean, mature system. Its persistence is a cosmic paradox, so where is all this dust coming from? The leading theory points to a hidden, violent realm just beyond the star's sight. The ring could be the aftermath of a colossal collision, a place where countless comets are constantly smashing into one another. Imagine a distant version of our own Kuiper belt, a frigid repository of icy bodies left over from the system's formation. In a young system, this belt is stable, but in this old star's neighborhood, something has stirred the pot. Perhaps the gravitational nudge from a passing star or the slow migration of a giant planet has destabilized the orbits of these comets. Now, instead of a peaceful reservoir, it has become a chaotic demolition derby. With every impact, comets are pulverized into fine dust, replenishing the ring as quickly as the star can clear it away. This creates a permanent, dusty shroud, a celestial crime scene where destruction and renewal are locked in a perpetual cycle. This star is a living fossil, a system that has somehow preserved the violent conditions of its youth, forcing us to wonder if our own quiet solar system is the exception and not the rule. Even a cosmic masterpiece like the Whirlpool Galaxy can keep a dark secret in plain sight. For centuries, astronomers have admired M51 for its stunning spiral arms, a classic example of galactic structure. Yet, recent observations have revealed a phantom lurking in its core, a supermassive black hole that had remained completely hidden from view. This monster was not found in some distant, obscure galaxy, but right in our cosmic backyard, concealed within a dense, swirling shroud of gas and dust. The reason we missed it for so long is simple. Our traditional telescopes, which rely on visible light, are blind to objects obscured by such cosmic fog. It is like trying to spot a light bulb through a thick, woolen blanket. The breakthrough came with a shift to a different kind of vision. Astronomers turned to the sharp eyes of the Chandra X-ray Observatory, an instrument designed to see the high-energy X-rays that can punch through obscuring material. When they pointed it at the whirlpool's heart, they detected a brilliant, flickering beacon of X-ray light. This was the telltale signature of a supermassive black hole actively feeding. As matter is pulled into the black hole's intense gravitational grip, it forms a swirling, superheated disk that emits tremendous amounts of X-ray radiation before vanishing across the event horizon. The fact that this emission is so bright and variable means we are catching this hidden monster in the act of a cosmic meal, its violent feast revealed only by the high-energy screams it lets out. This discovery fundamentally changes our search for these gravitational giants. It suggests that many of the universe's supermassive black holes, even in galaxies we thought we knew intimately, could be hiding behind similar veils. We are only now developing the tools to pull back these curtains, finding that the cosmos is far more crowded with these dark hearts than we ever imagined. A cosmic chameleon shifts its form right before our eyes. Deep within a binary star system, astronomers have found a neutron star that refuses to stay in one state, transforming itself from a radio pulsar into an X-ray pulsar and back again. This is not a one-time change, but a continuous, cyclical metamorphosis, offering a rare live demonstration of how these stellar corpses evolve over millions of years. The key to its shifting identity lies in its relationship with its companion star. The neutron star is locked in a gravitational embrace with a sun-like star, slowly siphoning material from its partner's outer atmosphere. This stolen gas does not fall directly onto the neutron star. Instead, it forms a vast, swirling disk of superheated matter called an accretion disk that spirals inward. The behavior of this disk dictates everything. When the accretion rate is low, the neutron star's own powerful magnetic field and rapid spin can fight back. It pushes the incoming gas away, funnels it toward its magnetic poles, and beams out intense radio waves that sweep across space like a lighthouse. In this state, we see it as a radio pulsar. But then, the flow of material from the companion star increases. The accretion disk grows denser and more powerful. Eventually, the pressure of this infalling gas becomes so immense that it overwhelms the neutron star's magnetic field, pushing it aside and crashing down onto the surface. When this happens, the entire character of the system changes. The energy released as this gas slams into the solid, ultra-dense surface at nearly the speed of light is staggering. It heats the impact zones to temperatures of millions of degrees, causing them to glow with intense X-rays. The radio beams are effectively smothered, and the object transitions into an X-ray pulsar, flashing its high-energy signal with every rotation. This back-and-forth struggle between the magnetic field's push and the accretion disk's pull creates a celestial toggle switch. We are witnessing a fundamental balancing act that governs the life of many pulsars, a dynamic process usually inferred from studying different objects at different stages. Here, in this one system, we can watch the entire cycle play out in real time, seeing firsthand how a pulsar's diet can completely alter its cosmic appearance. The heart of a distant galaxy is breathing, and its exhalation is a bubble of pure energy large enough to swallow entire solar systems. This colossal structure, recently observed in a new frequency band that reveals its true scale, is not a gentle soap film but a violently expanding sphere of multimillion-degree gas. It was forged by the galaxy's central supermassive black hole, a monster that occasionally awakens from its slumber to unleash twin jets of charged particles traveling at nearly the speed of light. These jets act like cosmic blowtorches, plowing into the surrounding intergalactic gas and inflating a vast cavity, a bubble of nothingness wrapped in a searing hot shell. This is the universe's most powerful form of feedback, a self-regulating mechanism that prevents galaxies from growing too large for their own good. When a galaxy becomes too rich with gas, it can trigger an immense burst of star formation, a stellar baby boom that would rapidly consume all the available fuel. But as this happens, more and more material also falls toward the central black hole, feeding it and causing it to erupt. The resulting energy bubble then pushes back, violently heating the surrounding gas and blowing it clear of the galaxy's core. This disperses the star-forming fuel, effectively putting a lid on further stellar birth. It is a cosmic cycle of creation and suppression, where the darkest object in the galaxy controls the fate of its light. Without this black hole feedback, galaxies would burn too bright and too fast, exhausting their resources and collapsing into disarray. These bubbles do not just shape their home galaxies, they sculpt the very space between them. As they expand into the intracluster medium, the thin soup of superheated gas that binds galaxy clusters together, they redistribute matter and energy on an epic scale. They can carve out vast sound wave-like ripples in the gas, channel heat to the cluster's outer edges, and prevent the cool gas at the center from collapsing to form new stars. This newly observed bubble gives us a clearer picture of this dynamic process than ever before, revealing how the most destructive forces in the cosmos are also essential architects, using their fury to build the large-scale structure of the universe we see today. These ancient star clusters are cosmic time capsules, forged when the universe was a mere fraction of its current age. Astronomers have discovered a distant galaxy harboring a population of globular clusters so ancient they predate the formation of the galaxy itself. These are not the familiar clusters of our modern Milky Way. These relics are composed almost entirely of hydrogen and helium, the pristine elements cast out from the Big Bang, with only the faintest traces of any heavier metals. Their existence in such a pure, unadulterated state tells us they were among the very first structures to ever ignite, lighting up the cosmic dark ages. Their incredible age and primitive chemistry force a radical rethinking of how galaxies were assembled. It appears the earliest galaxies did not form in one smooth, monolithic collapse. Instead, they were likely cobbled together from pre-existing building blocks like these ancient clusters. Imagine the first galaxies not as singular, glowing clouds, but as cosmic cities under construction, with these brilliant, dense star clusters as the foundational bricks, gravitating together to form a larger whole. The clusters we see in this distant galaxy are the survivors of that violent, chaotic construction phase, having endured for over 13 billion years. Their survival is a testament to their incredible density, allowing them to resist being torn apart during galactic collisions and mergers. Each one of these clusters is a living fossil, a direct window into the universe's first generation of stars, revealing a time when the cosmos was just learning how to build the magnificent structures we see today. That fading heartbeat from a galactic core finds a distant, violent parallel in a sudden echo from the void. Years after a titanic gamma-ray burst flashed into oblivion, astronomers have detected its ghost, a faint radio whisper that simply should not be there. This is the lingering afterglow of one of the universe's most powerful explosions, an echo that has persisted long after the initial fireball faded from view. A typical gamma-ray burst is a brief, catastrophic event, often signaling the death of a massive star or the merger of dense stellar corpses. For a few fleeting seconds, it can outshine an entire galaxy, emitting more energy than our Sun will in its entire 10 billion-year lifetime. Then it vanishes, leaving behind an expanding cloud of debris and a fading afterglow across other wavelengths. Normally, this afterglow disappears within months. The fact that we can still detect 1 year later is a monumental clue. This persistent signal is not coming from the explosion site itself. Instead, it is a reflection. The initial flash of the gamma-ray burst acted like a cosmic camera flash, illuminating everything around it in a sudden, brutal pulse of energy. That light traveled outward and slammed into clouds of interstellar material, the vast, diffuse gas and dust that floats in the space between stars. The energy from the blast caused these clouds to become energized or ionized, and they have been slowly re-emitting that energy ever since, like a cave wall continuing to glow after a brilliant flash of lightning. We are essentially hearing the echo of that long-dead explosion as it bounces around the galactic neighborhood. By studying the precise properties of this faint radio echo, scientists can perform a new kind of cosmic forensics. The strength, the frequency, and the rate at which this echo fades tells a detailed story about the environment the gamma-ray burst occurred in. It reveals the density and composition of the interstellar material that was in the path of the blast, painting a picture of the stellar nursery the progenitor star was born in. A loud, long-lasting echo suggests the star was surrounded by a thick, dense cocoon of gas, perhaps shed in violent stellar winds before its final collapse. A fainter, quicker fade might indicate a cleaner, more evacuated region of space. This echo transforms a single, fleeting point of light into a lasting probe, allowing us to study the life and death of a star through the ghost it left behind. This final cosmic mystery arrives not as a flash of light, but as a single, impossibly energetic particle. Astronomers have detected an ultra-high energy cosmic ray, a subatomic projectile carrying more punch than a professionally thrown fastball. Its energy level is so immense, it defies all known physics for how such a tiny speck of matter could be accelerated across the universe. The true shock came when scientists tried to trace its path backward to a source. They expected to find a colossal cosmic engine, perhaps a supermassive black hole or a merging galaxy cluster, the only places thought capable of producing such a powerful particle. Instead, the trail led them to a blank patch of sky, a void of empty space devoid of any known celestial object powerful enough to be the culprit. It is like finding a cannonball flying through the air, but when you look for the cannon, there is nothing there at all. This particle is a ghost bullet fired from an invisible gun. The sheer energy it carries is almost beyond comprehension. To reach such velocities, a particle must be accelerated by unimaginably strong magnetic fields, ones that stretch across vast distances in space. Our best theories point to active galactic nuclei or gamma-ray bursts as the only possible natural accelerators, but those are completely absent from this particular direction. The particle itself is likely a proton or the nucleus of a heavier atom, traveling at a speed so close to light that its journey across cosmic distances feels almost instantaneous from its own perspective. When it finally slammed into Earth's atmosphere, it created a spectacular cascade of secondary particles, a sprawling air shower that spread across miles, which is how our detectors on the ground were able to pinpoint its incredible energy. This one particle challenges the very foundations of particle astrophysics. It suggests there are either colossal, unknown objects lurking in the dark, hidden from all our telescopes, or our understanding of how particles interact with magnetic fields across the universe is fundamentally incomplete. The empty space from which it came is now a target for intense scrutiny, a quiet sector of the cosmos that may be hiding one of the universe's most powerful and secret engines. From ghost bullets fired by invisible cannons to zombie stars that survived their own death, these 30 cosmic discoveries reveal a universe of breathtaking strangeness. We have wandered through metallic skies and silent voids, witnessed the frantic dance of black holes and the stubborn pulse of stellar heartbeats. Each of these oddities, from the dark galaxy with no stars to the planet with 3 suns, is more than just a scientific curiosity. They are fundamental challenges, cosmic puzzles that force us to rewrite the textbooks and question our most basic assumptions. The cosmos is not a placid, predictable place. It is a vibrant, chaotic, and deeply mysterious arena where the rules are still being written. Every one of these findings proves that our imagination is no match for the sheer, unbridled weirdness of reality. Which of these 30 oddities captured your imagination the most? Was it the rogue planet with its ghostly auroras, the ancient galaxy shining in the void, or something else entirely? Let us know in the comments, and if you are ready for more journeys to the edge of understanding, be sure to subscribe for our next cosmic adventure.